Well, we have learned about the vector equation of a line. So let's try a question to understand how we can actually apply vector equation in exam view. Yeah. So let's say we have to find the equation. Okay. So here we have to find the equation of the line that passes through point P and Q. Okay. So how can we do this? Okay. So let's say there is a line. Okay. Let's say there is a line. What they are saying is there are 2 points. Okay. There are 2 points P and Q. Okay. There are 2 points P and Q such that P is 5 minus 2 comma 3 and Q is 1 comma 1 comma 4. All right. So to find the vector equation, we know a vector equation is in the form R is equals to A plus lambda B. So A is the position vector. It is any point on the line. Okay, it can be any point on the line. So it is the position vector. And we have B, okay, the direction vector. The direction vector. So in this question, we have P and Q. We have P and Q. So we can use P or Q as the position vector. Okay. So A can be either 5 minus 2, 3 or 1, 1, 4. That is our choice. Okay. So A can be any one of these vectors. That's not an issue. Now we have to find out what's the direction vector is. Okay. So if you consider this line, the direction of this line, okay, the direction of this line is this. Okay. Or you can say it is in this direction. Whatever the direction, it depends on the points P and Q. Okay. So if I find out the vector PQ, okay, if I find out the vector PQ, that will be the direction vector in this case. Okay. Or it can be QP also. It can be QP also. It doesn't matter. Why? As long as the vector depicts a direction, that's enough. Okay. So it can be in this direction or it can be in this direction. That doesn't matter. So I will just take PQ so that it will be easy for us. So how can I find PQ in this case? Well, think of this. P has a position. P is a point. If it has a position, well, then I can say OP is equals to 5 minus 2, 3. Similarly, I can say OQ is equals to 1, 1, 4. Why? Both of them have position vectors. Now I can easily find out PQ. Why? PQ will be equals to PQ will be equals to PO plus OQ, which I can rewrite as minus OP plus OQ. Okay, so here we have minus 5 plus, sorry, actually we have 5 minus 2, 3. But when it becomes minus OP, it will be minus 5 plus 2 and minus 3. Okay, so if I add these two, I will be getting what? Minus 4, 3, 1. So now I know the direction vector is minus 4, 3, 1. Okay, so B is equals to minus 4, 3, 1. We have found out what A is and what B is. You can give two answers. Okay, you can give two answers. You can say R is equals to, okay, 5 minus 2, 3 plus lambda minus 4, 3, 1. Or you can say R is equals to 1, 1, 4 plus lambda into minus 4, 3, 1. Okay, so these are the two equations that we have come up with for this specific line which passes through the points P and Q. Okay, this is one of the simple examples that you can use to find the vector equation of a line. Okay, now let's look at another question. Okay, now let's look at another question. Okay. What does this question say? Okay. Well, it says that in this question, they have made the question really easy. Why? They have given that we need a line that is parallel to vector q, and they have given the q. So they are mentioning the direction vector here. They are mentioning the direction vector here. So we already know if we are writing r is equals to a plus lambda v, we already know b will be equals to q in this case. And they have also given you the point. They have also given you the point which is on the line. Okay, if a line passes through point P, we can say point P is on the line. Yeah, point P is on the line. So it can be rewritten as, yeah, it can be rewritten as a vector equation. It can be given as R is equals to, so we have the position vector 2, 4, 6 plus lambda, and then we have B, in this case that is Q, vector Q. So I can write down 3, 5, 7. Okay, 3, 5, 7. All right. Now, shall we try and write down this specific same line, the vector equation for the same line, by using different direction vector as well as different position vector. Pause the video and try it by yourself, then come back and do this. Okay. So now let's do this. So R is equals to, here instead of 2, 4, 6, what I'm going to do is I'm going to replace lambda with 1. Okay, if I replace lambda with 1, I have another point on the line. Okay, so it will be 5, 9, 13. And I'm going to use that as the position vector here. I'm going to use that as the position vector here. And I'll keep lambda as lambda because it doesn't matter, because it's a real number. It can be any number. And instead of 3, 5, 7, I'm going to use 6, 10, 21. Okay, 6, 10, 21. It doesn't matter as long as this is a multiple of, as long as this is a multiple of this direction vector. Because multiple means the scalar product, and the direction only, it must be equal. The direction only equal to the direction vector given. Okay, and we know 6, 10, 21 will be in that direction. Okay, so these are the practice questions that we can do to understand what is the vector equation of a line. We know R is equals to A plus lambda B. A is the position vector, B is the direction vector. Okay, A is the position vector, B is the direction vector. Thanks for watching the 12th video in our vector series. If you found these practice questions on the vector equation of a line helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors. Follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.